Hello and welcome to this GCSE chemistry video about testing for negative ions. In this video we'll cover 3 different negative ion tests, starting with the halide ions, moving from there into sulfates, and finishing by looking at the carbonates test. 2 of the tests for negative ions involves the formation of a precipitate in a precipitation reaction. And a precipitation reaction occurs when 2 solutions containing soluble substances are mixed together, resulting in the formation of an insoluble solid called a precipitate. This solid appears as a cloudy or grainy substance in the liquid, and gradually it will settle at the bottom of the tube, or maybe it can be filtered out. The colour of the precipitate that forms in the reaction is often distinctive and can often be used to identify the presence of one or more ion in one of the solutions. And I should say that it doesn't really matter which chemical you pour into the other, because for instance, if mixing tube A into tube B produces a white precipitate, pouring the contents of tube B into tube A will also produce that same white precipitate, because we're still ending up with the same ions mixed together in the same tube. It just might be the tube on the left or the tube on the right. The halide ions are ions of the group 7 elements, which are known as the halogens. And group 7 elements have got 7 electrons in their outer shell, which means that they need to gain 1 electron to fill their outer shell. And since electrons are negatively charged, the halogens form ions with a 1- charge. And the ones that you need to know about are Cl 1-, Br 1-, and I 1-. And when the halogens form ions, we don't call them halogens anymore, we call them the halide ions. And so Cl 1- is called chloride, and then we have bromide, and then we have iodide. And it's really important that we make this clarification between the element and its ion. Chlorine with the formula Cl2 is the element, and chloride with the formula Cl 1- is the ion. Compounds containing the halide ions cannot be identified simply by observing the solution, because the majority of common halides, for instance sodium chloride, usually form colourless solutions, and so to look at they are indistinguishable from water. The test for halide ions only works if we have a solution, and so if you have a solid sample of a suspected halide, the first thing that we need to do is dissolve it in a test tube in some distilled water to produce a solution. And then if we have our solution that we suspect contains a halide ion, let's assume that it does contain a halide ion and assume that it is the chloride ion. To prove the presence of this chloride ion, we need to add 2 chemicals. The first chemical is nitric acid and the second chemical is silver nitrate. When we add some nitric acid to our test tube, nothing observable is likely to happen, but when we add our silver nitrate to the test tube, we will produce a precipitate, and the precipitate will be a distinctive colour. What we produce with the chloride ion is a white precipitate of silver chloride, and so the identity of this precipitate is silver chloride. If we had a second tube and this contained the bromide ion in solution, and we repeated those same 2 tests, adding the nitric acid and then the silver nitrate, we would produce a cream precipitate of silver bromide. And then if we had a third test tube that we suspected contained the iodide ion in solution, we would add again the nitric acid from a pipette and again the silver nitrate, and once we added the silver nitrate solution, we would see a distinctive yellow precipitate, proving that we have produced the silver iodide, which is insoluble in water, hence the precipitate, and that was proving that originally we did have that iodide ion present in solution. There are a number of common compounds that are sulfates. For instance, potassium sulfate is obtained through mining and it is used directly as a fertilizer. We can also produce sulfates when sulfuric acid reacts with bases. The sulfate ion, which has got the formula SO42-, showing it's a -2 charge ion, can be tested for using a simple test tube-based reaction. This test only works really if we have a solution, which means that if you've got a solid sample of this suspected sulfate, the first step is to dissolve this sample in distilled water in a test tube. And then we'll have a solution that we may think contains sulfate ions. And so to test for the presence of the sulfate ion, we would need to get two chemicals, and they are barium chloride and hydrochloric acid. And so using a pipette, we'd take a small amount of hydrochloric acid and we'd add that to our solution, and then we'd add our barium chloride solution to the same test tube. And if we have got the sulfate ion present, we would see the positive result of a white precipitate forming. And that white precipitate is in fact the compound barium sulfate, which is insoluble in water, which is why we see it as a solid precipitate. Testing for the carbonate ion utilises the fact that carbonates are bases, and bases are the chemical opposites of acids, and so carbonates react with dilute acids. In general, when you take an acid and react it with a metal carbonate, they will react together to produce a salt and water and carbon dioxide gas. For instance, if we had some sodium carbonate in a test tube, this could be a solution or a solid, either will work, and if we add some hydrochloric acid to it, we will produce sodium chloride, which is the salt, and water, which we wouldn't observe because it was already dissolved in water, and we would produce carbon dioxide gas. And so we would observe bubbling or fizzing or effervescence. We could call it any of those three things. If we move on now and take a look at the symbol equation, sodium is in group 1, so it will be a 1+ ion, and the carbonate ion has a formula of CO3 2-, and so sodium carbonate would have the formula Na2CO3, because those ions have to be balanced in terms of the charge. Now the sodium carbonate, let's assume it's a solution, so I'm going to give it a state symbol AQ. Hydrochloric acid has got the formula HCl. That will be a solution as well, so AQ for that to show that it's dissolved in water. When they produce the sodium chloride, that will also be dissolved in water, so that will be NaCl aqueous, and water is H2O, and that's a liquid, so that's got the state symbol L, and we make carbon dioxide gas, and so we give that the state symbol of G. And to balance this equation, we need to have 2 sodium on the right-hand side because we already had 2 on the left. And remember, we can only balance equations by putting numbers in front of something's formula because they act as multipliers. And now we've put that 2 in front of the NaCl, we have 2 chlorine atoms on the right-hand side, and so we need to put a 2 in front of the HCl on the left-hand side, and that then gives us 2 chlorine on both sides of the equation. As we know, carbonates react with dilute acids, and so to test for the presence of the carbonate ion, we add an acid to the tube suspected of containing the carbonate ion. And if the carbonate ion is present, we will see bubbles of gas, and that gas that is produced is going to be carbon dioxide. But carbon dioxide is odourless and colourless, so you can't tell just by looking at it that it is carbon dioxide, and so we need to get some proof. And we know that if we bubble carbon dioxide gas through lime water, that lime water will go milky or cloudy. And so to make sure that we can make this happen, we'd put a bung into the tube where the gas is being produced, and then we'd make sure that there is a delivery tube in the bung which will deliver the gas into a second tube where we've got the lime water, which is also known as calcium hydroxide solution. And if that lime water goes cloudy, we are proving that carbon dioxide is being produced, which is proving that carbonate ions must have been present in the original test tube. The possible presence of the carbonate ion is why we acidify silver nitrate during the halide ion test and barium chloride during the sulfate test, because the presence of carbonate impurities can interfere with the results that we're expecting to get. And the reason that this is an issue is that carbonate ions will react with barium ions and also with silver ions to produce white precipitates. And this could be misleading because if you added barium chloride to an unknown solution and you got a white precipitate, you may think that sulfate ions were present in the tube. And similarly, if you added silver nitrate to an unknown solution and you got a white precipitate, you would conclude that the halide ion was present. Probably you'd conclude that the chloride ion was present. And so by adding acid, any carbonate ions that are present as impurities will react and be removed as carbon dioxide gas. And this ensures that if a white precipitate forms when you add barium chloride or silver nitrate, we can say confidently that it is due to the presence of the sulfate ion or the chloride ion, depending on the test that we're carrying out. Okay, that's the end of this video. Thanks for listening.